This short lecture covers control functions in SQL. These are the analog of the question-mark:: operator found in many modern languages. Let's start with the if function. This is the principal control function. If you're familiar with the question-mark:, sometimes termed the conditional or ternary operator in C, C#, Java, JavaScript, Ruby, or any other C syntax language, then you'll understand this function easily. If takes three parameters. The first is a test, and the second and third are values to return if the test is true or false, respectively. So for instance, if val1 less than val2, then val1 else val2, those three parameters, that call returns val1 if val1 is less than val2, and otherwise it returns val2. In other words, it returns the minimum of val1 and val2. You can use any test you like and any choice of two return values, though they should be of the same type. And the first parameter can be a standard Boolean test, as in our example just now, or any expression that returns a value. The specific rule for whether the test is true is that it returns a non-zero, non-null value. So it's a little like JavaScript rules for truthiness. 0 and null both count as false. And as in C or JavaScript, even a negative value is true as long as it's non-zero. So let's try this out with a question. What does the following do, and why does it do it? And review the string docs if you need to remember what things like concat are, and assume content is some reasonable string. Coming back from a pause, I won't run it because I don't have a database behind this right now, but it prepends error to content if the word lowercase error appears anywhere in content. Recall, by the way, that the 1 that was passed to locate here indicates a start at the beginning of the string, since it's one indexed, and the locate returns 0 if it doesn't find the specified substring. So as a result, this test will be true if we find the string error in content, and if so, we will concatenate error, otherwise nothing, and then the final piece of the concatenation is the content itself. And then question 2, write a single expression that finds the maximum of all three values v1, v2, and v3. Use nested if calls to do this. And coming back from a pause, one way to do this, and probably the simplest, would be to write if and then have the test v1 greater than v2 and v2 greater than v3. And if that is true, we'd return v1. It's clearly the largest in that case. Otherwise, we'll do as a second call for the else part an if of v2 and v3 and return whichever of the two of those is largest. Now, you can do anything you need to with if, but SQL offers the usual run of syntactic sugar. For instance, if we have a function that's an if-else, we may as well have one that's a case statement too. SQL operator, it's not a function, it's an operator, case fills this role. You may write an expression like this as a test in any SQL statement, and you can have as many additional when clauses as you like in it. So you start with case, and then when and test 1, then you get value 1. When test 2, then you get value 2. And a final optional else, value 3, and then an end that is not optional. This returns the value that corresponds to the first test that's true, or to the else case if none are true. Now, as I said, the else is optional. If no test is true, and if there's no else, the result is null. So, question 3. Use a case statement, or case expression, I should say, to rewrite the 3 value maximum from question 2. So, coming back from a pause, you'd get something like this. Case when v1 greater v2 and v1 greater than v3, then v1. When v2 greater v3, then v2, else v3 end. Now, another convenience function is if null. It's quite common to want to replace a null value with some default in select or update statements, and if null is designed for this purpose. If you write if null val1 val2, thus, you can read it as use val1 if it's non-null, otherwise fall back to val2. This will return val1 if val1 is not null, and otherwise it returns val2. A typical use might be to say if null score and then quote NA to replace a null score value with an NA. So question number 4, try rewriting if null val1 val2 using if, and think very carefully about the test. Coming back from a pause, what you're going to have to write is if val1 is not equal to null, is not null I should say, then val1, otherwise val2. Note that if val1 val2, just using val1 itself as a test here, will not work. And in fact, the reason it will not work is another question, question 5. Why won't that work? So for a more concrete example of what to think about here, what would be wrong with replacing if null score 100 with if score 100? Coming back from a pause there, well, this would replace score with 100 if score were non-null but 0. So lots of 0 score people might be pleased, but it wouldn't be correct. This kind of error is probably why if null exists. It's preferable to use if null over if when you're trying to provide a null replacement value.